morning, students. You are welcome to this another important edition of presentation on chemistry. Now, you all know that chemistry is a branch of pure science that deals with properties of matter, composition of matter, and its uses. So, if this information has been established in your mind, a term to you, it means you are in the journey of learning chemistry. So in today's edition, we shall be looking at the topic organic chemistry. Now in this organic chemistry, the things we'll be covering include introduction to organic chemistry. We'll be treating characteristics of organic chemistry, uniqueness of carbon, terminology in organic chemistry. So let's get started. Now, organic chemistry can be defined as the study of carbon and its compound with exception of oxides of carbon, sulfides of carbon, and other carbon derivatives. All right, so that's what we refer to as organic chemistry. So we study particularly, we are studying about carbon and its compound. But what we don't study in organic chemistry, we don't study oxides of carbon, we don't study sulfides of carbon, and some other derivatives, which I am going to mention in course of this class. Now, we want to look at characteristics of organic chemistry. Characteristics of organic chemistry. Now, when we say characteristics, what do we mean by that? We are trying to say, when you see an organic compound, how do you know them? Number one, organic compounds are volatile in nature. They are volatile in nature. Organic compounds are non-polar substance. Hence do not dissolve. You can see that we have said that the characteristics of organic chemistry is number one. Organic compounds are volatile in nature. Organic compounds are non-polar substance, hence do not dissolve in polar solvent, so that's water. Now, in your domestic environment, when you get something like oil and put it inside water, you see that the oil will not dissolve in water. Why is it so? Chemistry explains about that. He explains that because the oil is an organic compound, it cannot dissolve in a solvent like water. And remember, we said that organic compounds, they are, from the characteristics, they are non-polar substance. So get it straight. Non-polar substance do not dissolve in polar substance. So anytime you put oil in water and it doesn't dissolve, just know that it is an organic compound. Are paying attention? So organic compounds do not dissolve in polar solvents. I hope it's clear. But when you bring a polar solvent, a non-polar solvent that is related to organic compound, and you mix them together, it will definitely dissolve. So this is one of the essential characteristics that this is an organic what? Compound. I hope it's clear now. When we say organic chemistry, we are talking about organic compounds. Okay, let's forge ahead to look further characteristics of it. Okay, another thing is that organic compound or organic chemistry, organic compound are covalently bonded. Whenever you see an organic compound, they are covalently bonded. That's one of the essential characteristics of organic compounds. So these three characteristics are the things whenever you see in an organic chemistry or organic compound, you just know that this is an organic compound. All right, having established that, we'll go to the next in the content, and that is uniqueness of carbon. Uniqueness of carbon. Now, why are we studying carbon? Why is organic chemistry talking about carbon? Or what is the relevance of studying what? Carbon. Now, let's see the reason why we chose carbon. Now, one of the reasons we chose carbon is that carbon has the ability to catenate. Carbon has the ability to what? Catenate. And this is called catenation. What does it mean? That is to say that carbon can combine with itself to form straight chain, branch chain, and circular. So we look at the uniqueness of carbon. We say number one is that carbon has the ability to catenate, and we will talk about catenation. We are talking about how carbon can combine with itself to form straight chain, branch chain, and ring chain structure. So by this, what we meant is that carbon can form straight chain. So this straight chain like this, it can form straight chain like this. It can form straight chain like this. So this is what we call straight chain. This is labeled as straight chain. So carbon also has the ability to form branch chain. You can have something like this. So this is a branch chain compound. This is a branch chain. So this is one of the uniqueness of carbon. It has the ability to form branch chain. So this is called branch chain. So students, these are very important. You take note of them. These are the journey that we are on organic chemistry. For these things are relevant in the pursuit of organic chemistry. Now we're going to look at it. Also form a ring structure, something like this. So you can see that it's forming a ring structure. This is called a ring chain. A ring chain. So this is one of the uniqueness of carbon. This is the major reason why we chose carbon. Out of all the compounds, we chose carbon, and we are studying carbon in organic chemistry. Now we are going to look at another reason why we chose carbon. Number two is the ease at which it combines with hydrogen, halides or halogen, etc. So the ease at which it combines with hydrogen, halogen, and etc. These are the reason why carbon is unique. Okay, let us see one more reason why carbon is unique. Number three reason why carbon is big is that carbon has the ability has the ability to form one single bond, two double bond, and three triple bond. So what we are trying to say, that is to say that what we are saying now, for example, you can see a carbon forming a single bond. So this is a single bond, all right? The carbon is forming a single bond with itself. Okay, it's forming a single bond. Then you can see also carbon can also form a double bond. Carbon can also form a double bond. So this is a double bond formed by carbon. And last it says triple bond. Carbon can also form triple bond. Can also form triple bond. So these are the various, one of the reasons or the three reasons why we say that carbon is what? Unique. So students study this very well. They are very essential for the learning of organic chemistry. Now, we are going to look at several terminologies that are used in organic chemistry. Let's look at several terminologies that are used in organic chemistry so that when you encounter them, you appreciate them, you know that these things are relevant and you know their meaning. I believe you are enjoying the class. Sit tight and make sure that the class is enjoyable. Now, let's look at terminologies in organic chemistry. Okay, so the terminologies that we have in organic chemistry, number one is homologous series. Homologous series. So, homologous series, this is the family of organic compounds that follows a regular pattern in which the successive member differ from the next member by the CH subscript 2. So that's the meaning of homologous series. That's the meaning of homologous series. Now let's demonstrate this. In homologous series, for example, we have examples of homologous series. Examples of homologous series. Number one, we have the alkene. And number two, we have the alkene. And number three, we have the alkyne homologous series. Then, number four, we have the alkanol and host of others. But for the purpose of this class, we shall just treat these four major ones. We have many of them. We have, okay, let's take this one. Let's take, we have the esters. We have the arachidonic acid. We have the amide. All these things are the homologous series that we have in organic chemistry. But for the purpose of this class, we will restrict our discussion to alkene, alkene, and alkyne. So we want to start with the alkane family. We want to start to show the homologous series of the alkane family. Now, the homologous series, we want to look at the homologous series alkane. So for the alkane family, we have number one member, which is the methane. Please, students, we are going to explain. We're also going to state their formula, their molecular formula, please. More precisely, we call it molecular formula. So the methane has a molecular formula of CH4. Then the ethane has the molecular formula of C2H6. The propane, the next one we have is the propane. The propane has the molecular formula of C3H8. The butane, the fourth member is the butane. It has C4H10. Then we have the pentane. So the pentane is C5H12. Then the sixth one, we have the hexane. The hexane is C6H14. Then we have the heptane. The heptane is C7H16 in that progression. The next one is the cane. So the cane is C8H18. Then we have the ninth member, which is nonane. Nonane is what? C9H20. So in that progression, you can get the respective homologous series of alkane. So students, I believe this information is highly conceptualized. It is more of theories that will boost your knowledge. Okay, let's go to the next one. We have the 10th member, which is the cane. So for your decane, we have C10H22. Okay, but based on your level, I shall stop with this member now. Okay, now students, the first four members of the alkane homologous series, they are known as gas. What am I trying to say? The alkane, the methane, the ethane, the propane, and the butane are known as gas. Okay, this information has been stated so you can be able to study them and know them. In our next edition, we shall look at the next homologous series, which is alkene. I believe this information is very, very conceptual, and you've understood everything we have discussed. So in our live class, we will expand more on organic chemistry. Thank you for listening, and sit tight to enjoy this episode. Thank you.